Session 8 of the Numeracy lecture series. Parts and proportions. 1 in 4, 1 to 4. What's the difference? We touched on this when we did concentrations, chloroform water and all that, and we're going to work on it a bit more. So following on from last session, let's use a food theme again to try and understand how the parts and proportions stuff works. So if we had to make a gravy mix, for example, you've got half a litre of water, 2 teaspoons of powder. How many teaspoons for 1 litre? 2 litres or 250 mils. How much water for 6 teaspoons? That's the sort of questions that we're expecting you to answer with parts and proportions. So, liquids are often concentrated and need to be diluted with water. For example, we have a drink, and you might make that 1 part squash with 4 parts water. So if you have 1 litre of squash, it's going to be added with 4 litres of water, and that's going to make you 5 litres of drink. So 1 litre of squash, you added it to 4 litres of water, you got 5 litres of drink. So ultimately, that means that a fifth of the drink, 1 out of the 5 parts, is squash, and 4 out of the 5 parts is water. So to make 20 litres of drink, we need a fifth of 20, which is 4 litres of squash. So again, we come back to understanding relationships between numbers, but also working out that if you've got 1 litre of squash, you're adding it 4 litres, you're making a total of 5 litres of drink. Let's put this into sort of a question in context. A manufacturer of antifreeze for cars recommends a mix of 1 part of antifreeze to 3 parts of water for normal motoring. What fraction of the mix is water? Put that in your head quickly. 3/4. Because antifreeze is 1 part, water is 3 parts. That means the total number of parts is 4, and 1 out of those 4 parts is antifreeze, and 3 out of those 4 parts is water. Okay? So, if the question says antifreeze for cars recommends a mix of 1 part antifreeze to 3 parts water for normal motoring, what is the antifreeze? We just did that. So again, going back or going forward, we had 1 part antifreeze, 3 parts water. In total, we have 4 parts altogether, and the antifreeze is 1 out of those 4 parts. So, let's say we've got screen wash. You have to mix 1 part of screen wash with 20 parts of water. What fraction of the mix is wash? So if you look at that, you've got 1 part of wash to 20 parts of water. It means that the wash is 1 out of a total of 21 parts. Mix 1 part of wash with 20 parts of water. What is the water? What fraction of the mix is water? Looking at the same thing, you used 1 of wash, 20 of water. The total number of parts is 21, and the water was 20 out of those 21 parts. So it's 20 out of 21. How many litres of the mix will 10 litres of wash make? So now it's saying to you, the wash is 1 wash to 20 water. That's your proportions you're using. How many litres of the mix will 10 litres of wash make? Hopefully, what you found at this stage is you knew you were using 1 to 20. 10 litres will be 10 times the amount. So therefore, 20 turns into 200, giving you a total of 210 litres. So you worked out that if you then multiplied by 10, you got 200, but the total amount is 210 litres. Again, remembering the units. So how many litres of wash are needed to make 105 litres of mix? So this is turning it around slightly more. Now we're saying, how much of wash do we need if you have to make 105 litres of mix? You're ending up with 105 litres. It's again reminding you that it's 1 wash to 20 water. So it's 105 litres in total. Total number of parts originally is 21. 105 is 5 times 21. Hopefully you can see that quickly and easily, because you know 20 times 5 is 100, so 21 is 5 times that. You know it's going to divide equally because it's not going to have leftovers at this stage. So therefore the amount of wash is 5. So you're making 105 litres. The number of parts originally was 21. So you divide it down and it's 5. Let's go into a building site now. For engineering bricks, dry mortar is made with cement and sand 1 in 4. 1 in 4. This means out of the total of 4 units, 1 is cement. And therefore that means 3 are sand. Until now we've been doing 2. We've been doing all the screen washes and car washes and antifreezes, it's been 2. This is 1 in 4. So out of the 4, the total number of parts is 4, 1 is a cement. And that therefore means 3 are sand. 1 in 4 is therefore equivalent to 1 to 3. With 15 units of sand, you would need 5 units of cement. And this would make a total of 20 units. Okay? So exactly the same principles and mathematics are applied in this type of context too. Being careful that 1 in 3 is not the same as 1 to 3. It's very important that you distinguish the difference here. It's been repeated again because of how important it is that you get it right. 1 in 3 means the total number of parts are 3 and 1 out of them is the drug or the cement or the antifreeze or whatever. And 3 is a total number, so therefore 2 is a solvent. 1, 2, 3 means that you're using 1 part of the drug or antifreeze or cement to 3 parts of the solvent, which means you'll end up with 4 parts. So 1, 2, 3 is the same as 1 in 4. Excuse me. A lot of the mathematics used for these calculations is the same as for the master formula. So it's sort of, I'm hoping you're sort of seeing as we're going along the series that they are all just flowing towards the same sort of thing as to how you're using the techniques. So, let's do a bit of technique advice here. If you're making squash, you mix 1 part concentrate with 9 parts water, for example. This will give you 10 parts altogether, which means it's the 100% of the squash. So 1/10 of the parts are concentrate, so 10% is concentrate, meaning 90% is water. So if you have concentrate water squash, parts fraction percentage, remembering the percentage fractions and decimals we did earlier, this is why we did it. So here we are, we've got concentrate water squash, we've got the number of parts that they are, it therefore works out the fraction that they are, and you can therefore work out the percentage that they are of a solution. Okay. So, moving on then, if I say to you we have a 1 in 500 solution, this should mean to you that it is 1 over 500. That's the fraction. As a percentage, then that becomes 0.2%, and that's the strength. So if I gave you a 1 in 500 solution, you can work out the strength of that solution in percentage by first converting it into the fraction and then into the percentage. So again, if I have a concentrate, a diluent, and then the solution, the concentrate was 1 part, the diluent was 499 parts, and the solution was 500 because it's a 1 in 500. So if it's a 1 in 500 means the total amount is 500, and 1 of that, which is the concentrate, is a concentrate. That automatically means that the diluent was 499. You then can work out the fraction to be 1 over 500 and 499 over 500, and then the solution is 1. And you can then work out the percentage. So the concentrate is 0.2%. So this solution is 0.2% strength. A ratio concentration is often used to express the concentration of very dilute solutions. It expresses a number of parts, usually in milliliters, of a solvent within which one part of the drug is dissolved or dispersed. So for example, a 1 in 5,000 solution of a drug means that you've got 1 gram of the drug dissolved in 5,000 milliliters of the solution. Remember the grams and milliliters. So you've got 1 gram in 5,000 milliliters. So if a solution contains 10 milligrams of drug in 5 milliliters of solution, express this for me as a ratio concentration. Have a think about how you might approach this. Now, just trying to understand, to do this type of question, you firstly determine what concentration expression is required. As a ratio concentration is required, determine what volume of solution would contain 1 gram of drug. And then express that as a ratio. So, look at the solution. 10 milligrams of the drug is contained in 5 milliliters of the solution. That's what we know. You've got 10 milligrams of drug in 5 milliliters of solution. So 1 milligram of drug is in 5 divided by 10 mils of the solution. Therefore, 1 gram of the drug contained in 5 times 1,000 divided by 10 of the solution is 500 mils. I've gone from milligrams to grams, hence the times 1,000. Therefore, we have a 1 in 500 solution, because I told you that it would be in grams per milliliters, grams in milliliters. So you worked it out, and then you worked out in grams, and then you said, so it's 1 gram in 500 milliliters. Therefore, expressed as a ratio concentration, it's 1 in 500 solution. Let's look at another example. How many milligrams of adrenaline are contained in 10 milliliters of a 1 in 10,000 solution of the drug? Have a look at this. We'll go through it together in a second. Okay, so looking at it, same thing again. Convert the ratio, well, it's not the same thing because we've got the ratio this time. Convert the ratio to a quantity per volume expression. Then you calculate how much adrenaline is present in 1 ml of the solution. And then you calculate how much adrenaline is present in 10 ml of the solution. Because it's asking you how much is there in 10 ml. Okay, so let's do it. A 1 in 10,000 solution means that you've got 1 gram of the drug, of adrenaline, dissolved in 10,000 ml of the solution. That's the first thing you need to identify from this. 1 in 10,000 means you've got 1 gram in 10,000 milliliters. So 1 milliliter of the solution will contain 1 divided by 10,000 grams of adrenaline. Therefore, 10 mils of the solution will be that multiplied by 10. If you do your maths correctly, you should get 1 milligram. So again here, can't stress enough the importance of doing your maths correctly and moving the decimal places the right numbers, the right number of times left or right. Always have an idea of size you're looking for. So if instead of 1 you end up with 0.1, you know that you're actually not in the right ballpark figure. Or if you end up with 100, then you're not in the right area. Okay, so let's look at another one. A 10 ml ampule of a 1 in 200,000 solution of bupivacaine hydrochloride is administered to a patient. How many milligrams of the bupivacaine hydrochloride does the patient receive? So this again is a slightly different way of asking this question. It's a different information that's required. So again, have a think. What does that mean to you? Let's go through it together. What are the 3 steps first? What is the first thing I want to identify? I want to convert the parts expression, because that's been given to me, to a quantity per volume expression. Because I'm being asked how much of that drug is going to be given to the patient. Then I want to calculate how much of the bupivacaine is in 1 ml, and then I want to calculate how much there is in 10 mils. So let's actually do this. So 1 in 200,000 means I've got 1 gram of the bupivacaine in 200,000 mils of the solution. Okay? That's the first and the most important thing to do. Get the units right and get the numbers right. Don't miss out a 0 or anything. So 1 gram in 200,000 mils of the solution. So 1 milliliter of the solution will contain 1 divided by 200,000 grams of bupivacaine. So therefore 10 milliliters of the solution will contain 1 divided by 200,000 times 10. And again, the maths is done correctly, you should end up with 0.05 milligrams of the bupivacaine. Right, so those are ways these questions are generally worded. Let's just look at a bit of percentages and stuff. What is 1 in 200 as a percentage strength? Work that out. What is 1 in 200 as a percentage strength?
Yeah.
1 in 200 as a percentage strength is 1 divided by 200 multiplied by 100. That's 0.5. What is 1 in 250 as a percentage strength? This should be simple enough. 1 in 250 as a percentage is 1 divided by 250 times 100, which gives you 0.4. What is the equivalent ratio for a 10% solution? Now, pay particular attention here. These are obviously a trick question, so you mustn't get caught out. If we're looking for an equivalent ratio, 10% means it's 10 in 100 parts, which means it's the same as 1 in 10 parts. So 1 in 10 is the same as 1 to 9. So the answers were in 2 and they were not in ins. So you needed to pay attention to what the answers were in so you didn't get caught out. They wanted the answers 1, 2, whatever. Was it 9, 10 or 11? You worked out that 10% means that there's 1 in 10, which means it's the same as 1, 2, 9. And the last one, just to make sure we sort of got our head around this, what is the equivalent ratio for a 15% solution? Okay, so paying attention here. What is the equivalent ratio for a 15% solution? %15 is 15 in 100, which means it is the same as 3 in 20. The answers, again, note, were in 2s and not in ins. So the ratio, therefore, is 3 to 17, which would give you the total of 20 parts. So in summary, hopefully you understand ratio concentrations. Remember the units. Remember it's the grams per milliliters that you're looking at here. And also remember the difference between in and to, and working out from one to the other and how you would do it. So it's paying particular attention to the units.